Dear students, in this lecture, we will discuss one numerical problem related to superposition theorem. So, as per the statement of the numerical, we have to find out the current through 1 kilo ohm resistor in the circuit shown here. So, we have to find out the current through this particular resistance using superposition theorem, and we can assume all the sources to be ideal. Ideal source means that when we have to replace these sources here with their resistances, so a current source will be replaced with infinite resistance, that is open, and a voltage source is replaced with zero resistance, that is short. So let us see how to solve this particular circuit diagram using superposition theorem. First of all, we will find out the current through this particular resistance 1 kilo ohm because of this 10 milliampere source. So as per the superposition theorem, the current through this particular resistance is the algebraic current sum of all the currents produced by these sources in this particular 1 kilo ohm resistance when each source is taken or considered alone, right? So first step is to we will find out the current through this 10 milliampere source in this 1 kilo ohm resistance. You can start with any source initially. You can start with 12, 25-volt source or 15-volt source, whatever. But remember, we have to consider one source at a time. Now, what we will do with the other sources, we will replace all other sources with their resistances. So let us see how much current will be flowing in 1 kilo ohm resistance because of 10 milliampere source. So the circuit redrawn here, the first step is we will find out the current in 1 kilo ohm due to this source. So we will replace this 25-volt and this 15-volt source with the short circuit. And the reason is because an ideal voltage source has zero resistance, right? So the circuit redrawn here is this one. By applying all these steps, let's see, let us mark it here. This is I1, for example. Now, as you can see, the voltage source, 25-volt source, has been short. So this complete branch is short circuit. Now, if you have to find out the parallel combination of these two branches, so the parallel combination would be, let us say it is R dash, for example. So it is 0 into 3 divided by 0 plus 3. So R dash is equal to 0. Now what does it mean? It means that these two branches are acting as short branch basically. So we can redraw this circuitry as this circuit can be redrawn again like so. Taking the parallel combination of these two branches, we have this circuit here. Now in this circuit, we have, let us say this junction is X and this is Y, for example. Now when this 10 milliampere current reaches to this junction X, it will divide into these two branches here. And let us say this I1 current is flowing in 1 kilo ohm resistance, which we have to calculate. So as per the current division rule, according to CDR, current division rule. Now I1 is equal to, because I1 is the part of 10 milliampere current which is coming to this junction X. So it is 10 into 10 raised to the power minus 3 into. Now uh, the resistance of the branch opposite to this 1 kilo ohm. So there are two branches here, as you can see. This branch and this branch. So these two branches are parallel across this XY, these XY terminals. So it is 4 into 10 raised to the power 3 ohm and divided by sum of these two resistances because they are in parallel. So it is 5 into 10 raised to the power 3. So by using this equation, we can find out the value of I1 because of 10 milliampere source that is flowing in 1 kilo ohm source. Hence, the current through 1 kilo ohm, the I1 is equal to, it is 8 into 10 raised to the power minus 3 ampere, or I1 is equal to 8 milliampere. So this is, let us say, equation number 1 here. So, so we can conclude here that the current through 1 kilo ohm source, because of this 10 milliampere source, is 1 kilo ohm resistance because of this 10 milliampere source is 8 milliampere. Now, next we will try to find out the current through 1 kilo ohm resistance using 25 volt source and then 15 volt source. So let us see what answer we get. Now let us calculate the current through 1 kilo ohm resistance because of 25 volt source. Now, as per the statement of superposition theorem, we will keep one source activated, that is 25 volt, and we have deactivated 15 volt source by short circuiting it and deactivated the 10 milliampere source by opening this uh, part of this branch. Now we have this 25 volt source and we have to calculate the current through this resistance. How will we calculate? So let us assume that some current I is flowing here, and uh, when reaching to this particular junction, let us say these two terminals are X and Y. When this current I reaches to X, it will divide into these two parts. Let us say this is I1 dash and this is, let us say, I2 dash. Right. Now our objective is to find out the value of I1 current. Now, how will we find out? For that, we can again use certain circuit analysis technique available to us. So, because we have assumed that the current through 1 kilo ohm resistance because of 25 volt source is I2, so let us replace this notation with I2 here. So notation does not matter at all. You can take any notation. Okay, so this is I2 here. Now, uh, if you see, this I2 basically is the part of this I current which is dividing at this junction X. So how will we find out I2? I2 can be calculated by applying current division rule at junction X. Hence, I2 is equal to the current I into, now if you see, this current I is dividing in these two branches, right? And here we don't have any current, no current. Now, that means if you see, if you redraw this circuit, you can redraw it like this. This can be redrawn like this. and we are trying to determine the current. This is I current here. This is, let us say, current I2 dash, and this is current I2, for example, as assumed. So that means I2 is in this branch here. So these two branches, this and this, these two are in parallel to one another. So we can write I into 3 kilo ohm divided by sum of all these three resistances, 1 plus 4 plus 3, 8. So by using this equation, we can find out the value of I2. But we need I. Hence, what is I? I is equal to this 25-volt source divided by R equivalent. Now, what is R equivalent here? R equivalent is, now this is 3 ohm, 3 kilo ohm resistance. This is combined 5 kilo ohm resistance. So R equivalent is 4k ohm plus 1k ohm. These two are in series and the combination is in parallel with 3k ohm. So it is 5k ohm is in parallel with 3k ohm, right? So the resultant is, so the value of R equivalent resistance is 15 by 8 kilo ohm here by using this combination. And then by substituting this value of R equivalent in this equation here, we will get the value of I here. Now, I is equal to 40 by 3 milliampere, and when we substitute this I in this equation for I2, the value of I2 is 5 milliampere. So this is, let us say, equation number 2. Now let us find out the value of current through 1 kilo ohm resistance using 15-volt source. Now considering the 15-volt source alone and replacing all the other sources with their resistances, that is 10 milliampere source is kept open and 25-volt source is shorted here, we can calculate the value of current through 1 kilo ohm resistance. So as per the assumption taken, let us say the current is I3 here. Now let us assume that some current I, uh, for example, I3 dash is flowing because of 15-volt source in this branch. Now this current will flow in this way. It will reach to this junction, and these junctions are, let us say, X and Y. When this current will reach to junction Y, it will not go in this branch. Sorry, it will not go in this particular branch here. It will go in this branch here, this one, right? Why? Because if you apply current division rule at junction Y, now apply current division rule here. So let us apply just to understand this mathematically. Why we will not have any current here? No current would be flowing mathematically. This current will as it is flow in this branch, right? So let us say this current here is, for example, I3, as we assume, right? And it is current I. So let us find out the value of I3 as per current division rule. So I3 is equal to I into resistance of the branch here, this one, this parallel branch. It is 0, and the sum of these three resistances. So it is 4 plus 1 plus 0. So I3 is 0 ampere. That means, that means in this case, 1 kilo ohm resistance does not have any current due to 15-volt source. That is, I3, which we assumed is equal to 0 ampere. Right? So this is lattice equation number 3. Now our last step is that we have to find out the algebraic sum of all the currents in this 1 kilo ohm resistance. Now how will we find out the algebraic sum? That is also we need to understand. If we go behind in all these three circuits, in the first circuit, let us see this equation number 1. The current was flowing in this way. Let us say this is junction X and this is junction, let us say Y, for example. Because XY we have already taken, so we'll take it as A and B instead of X and Y. So this is A and B, for example. So the current is flowing from X to A, right? Okay. Now let us come to this circuitry here. The current is flowing opposite now. It is flowing opposite to the earlier case. Okay. Now let us come to the third case. Here the current is already 0. So we will write here the net current in 1 kilo ohm resistance as per superposition theorem is the algebraic sum of I1, I2 and I3, which is, now what is that current? It is equal to, so initially we got how much current? We got 8 milliampere, then we got 5 milliampere and then 0. So it would be 8 minus 5 minus or plus whatever, it will remain same. So it is 3 milliampere. So this is the answer. So this much current is flowing in this 1 kilo ohm resistance because of all the three sources available in the given network. So this is how we can solve any network using superposition theorem, specifically linear bilateral network, right? Thank you so much.